I've been chosen from all the animals in the world to introduce this next section of study for you. And I will introduce it by asking you a few questions. Would you like a partial plate? If you don't know what that is, ask a really old person. Would you accept a partial payment? Would you like a room with a partial view? Would you like the diagnosis partial blindness? Would you like a partial description of your date? Are you partial to spicy food? I know some animals that have a partial habitat. Would you like to stand in front of a partial judge? Have you seen a partial eclipse? After this introduction, are you in a state of partial collapse? Well, with no further ado, would you please title the next section of your comp book, Partial Fractions? I've been chosen to introduce this from all the animals because I'm heads above the rest, and so are you for studying this topic. Even though I'm a bit of a sponge head, I like partial fractions.
Okay. All right. Hope you enjoyed that introduction. And as you've been clearly instructed, please title your comp book Partial Fractions. Today is the 22nd, and here's the definition. It's writing a fractional expression as a sum of simpler rational expressions. So let me remind you what a rational expression is. A rational expression is x plus 7 over x squared plus x minus 6. Let me make that minus. Sorry, I think I said minus. All right. And as you notice, the word rational has the word ratio embedded in it. So that tells us a clue that there's going to be a ratio, which is a fraction. So here we have one. We have a polynomial, an expression with x over another polynomial in x. We are going to be assuming that the polynomial in the numerator is 1 degree below the polynomial in the denominator. If not, we'll have to get fancy, and I'll show you what to do if that comes up in your assignment. But for now, this is a basic kind that we'll be doing. When we are writing this in partial fractions, as it says up here, there'll be a sum. Where's the word sum? A sum of simpler rational expressions, or ratios. So I'm going to remember that this is a factorable expression. So I'm going to go ahead and factor it. So what numbers multiply to give you minus 6, yet add to give you the minus 1? That's how I think about it. So we get a minus 3 and a plus 2 is the factored form of that. So when I do that, I am going to write the simpler expressions over here with an unknown on the top because I don't know what it is. And I'm going to take one of the factors from the denominator. So I'll take x minus 3, and then it's a sum, so I'm going to add an unknown quantity and put that over the expression x plus 2. So that is how I'm going to do that. Sometimes that is called decomposing into partial fractions. So let's see how that works. I want an expression that is equivalent here, but I need to know A and B. So it's going to be equivalent to what's on the left. When I finish, the right and the left will still be equal, but there will be the A and the B will be known. So the trick now is to find the A and the B. All right, I'm going to go ahead and time this for a little bit. So I'll probably stop around 8 minutes since I've probably blabbed 4. All right, so let's look at this. The way to solve this with algebra is to get rid of all these denominators. And I'm going to do that by multiplying through by the greatest common denominator. This denominator has this, an x minus 3, and this, an x plus 2. This denominator has an x minus 3, and this denominator has an x plus 2. So I'm going to multiply through by the greatest common denominator. So it's going to be x minus 3, x plus 2. So I'm going to multiply everything by that. So you'll see if I multiply this times this, the expression here on the top, in the numerator, will cancel the denominator and leave an x plus 7. So that's sweet. When I get over to the a, there's going to be an a times this, but notice the x minus 3 is going to cancel the x minus 3, and we'll leave an x plus 2. And lastly, what will be left? See if you can tell me. All right. So just simple algebra will clear the denominators and give us this expression. Now, this expression is true for x equaling any value, so I'm going to let x equal something that will help me solve for a or b. So if I say let x equal minus 2, do you see why I chose that? So that a will disappear and we can solve for b. So I can let x equal anything that will help me. Does that minus show up? All right, so if I let x equals minus 2, I'm going to get a minus 2, substituting in a minus 2 everywhere there's an x. On the left, I get minus 2 plus 7, and then a times minus 2 plus 2. There's a 0, so that term will drop out. And x equals minus 2, and it's next to a minus 3. So pulling all that together, I get a minus 2 plus a 7 is a 5. And I get a negative 2 and a negative 3, which is a negative 5b. Dividing both sides by negative 5, I find out that b is equal to negative 1. So that works. So I'm partway there. All I have to do is find value for a, and I'm finished. So going back to the drawing board, I now can put in wherever there's a b, I can put in, where am I here? I can put in a minus 1, because I know that's true. Now, what should I let x equal to this time get rid of b and solve for a? Well, b is hooked to this x minus 3, so I'm going to let x equal 3. When I do that, you'll see the b will drop out. So putting in a 3 for x from left to right, I get 3 plus 7 equals a times 3 plus 2 plus b times 3 minus 3. So that's going to zero out my b, which was my plan. Actually, when I got to b, I could have written a negative 1 there. So I have a 10 equals a 5a. Dividing by 5, I get a equals 2. So I have solved this problem of partial fractions. So I can now say x plus 7, my original problem, over x squared minus x minus 6, that's what it was before I factored it, equals my a, I had found out was a equals 2. So when I get to this part, I'm going to put in a 2 over x minus 3 plus, so when I get to b, I know b is minus 1, equals minus 1 over x plus 2. It would be algebraically equivalent if you changed this to a minus and said 2 over x minus 3 minus 1 over x plus 2. All right, so this is called decomposition into partial fractions. So why would you want to do that? Well, one day you'll be sitting in calculus class And you will be asked to find the integral of this. And the integral of this is not so easy, but the integral of this is much simpler. So that's all I can really say about it for now. You can ask the calc students to see if they know what you're talking about. All right. The next section is also on partial fractions, but I'm going to add a complication. Instead of having a pretty basic one like that, I'm going to show you what to do when this complication arises. So let's say, I'll turn it over. Let's say we're doing this one. Where's my paper? Oh, it's down here. Lost it. All right, let's say I'm going to do 10x squared plus 12x plus 20 over x cubed minus 8. Now I picked that one